A couple of people I'd like to thank before I get started here. One, Mr. Garnett there. He phoned me in the springtime and said, "Joe, would you like to do a presentation on magnetos for the fall workshop?" And I said, "Yeah, I guess we could." So we'll have to get some material. He said, "But I wanted to cover my magneto in my boat, which is a Bosch." I said, "Yeah, we got a Bosch dishwasher, but I didn't know they made magnetos." But they did have a long history of making magnetos, probably still do. And Garnett started me on a track here to try and make some sense of magnetos and how they work and some common faults that might happen to them. Now, I know not everybody here has got a Coventry Victor engine, but hopefully you can apply these same principles to your St. Lawrence or Copper Jacket or whatever it is. Yeah. Can everybody hear me there okay?
Yes.
Okay. And just so I won't make any mistakes, I'd like to read from this manual, and then we'll do this together. I think it'll formulate some ideas in your head as where we're going. And maybe you can put a little tick mark for ask me something later on. And then maybe I could refer that to an expert. Anyways, the subject today is the Coventry Victor Magnetos 101. And make note here, these notes are not highly technical in nature and content. Some minor electrical theory is involved, but it's more important to concentrate on the day-to-day mechanical and electrical functions of the magneto. Well, let's keep it simple. If your magneto unfortunately has a failed internal condenser or other internal component, you will need more help than these do-it-yourself notes can provide. The repair will no doubt require some professional diagnostic assistance and a magneto repair facility to help resolve a lack of ignition spark. Gas engine and electrical principle explanation. I got this from a book, and when I started this question, I phoned a good friend who a lot of you know, Barry Miller, and he said, "Joe, every Dispro owner should have these books." He said they're old, but they're good. And this is the theory of automotive and magneto ignition. And he said, you should buy some of those. So 40 bucks later, I had a copy of each. And they really were worth the 40 bucks. For anybody who's got magnetos and interested in the history of ignition systems, that's a good read.
Okay.
And you can have a look at them there if you want later on. In it, this book is from 1916, and it was authored by Roger Bradbury Whitman, now in the U.S. Library of Congress, and you can order these off the internet if you want. The charge of mixture having been taken into the cylinder, the next step in the cycle is to set it on fire, or in other words, to ignite it. The setting on fire or ignition of the fuel mixture is of great importance, for if it's not done correctly, the engine will lose power or fail to run. Each charge of mixture will produce a definite quality of heat when it is burned, the best heat in turn being capable of producing a definite pressure. If the engine is to run efficiently and develop its full power, the greatest possible portion of this pressure should be utilized in driving the piston downward on a vertical engine, or in the case of the Coventry Victor, on the side stroke. If the ignition of the mixture is not correct, much of this heat will be wasted and only a small part will be left to produce pressure and power. Defective action of any of the engine parts will result in a waste of power, but a greater waste of power will be due to defective ignition than will be caused by anything else. And Bill, you had a quote there at lunchtime. What was that? About the engine, it could be perfect, but what was it you said at the table there? About ignition? Magneto? I should have wrote it down. It was a good one anyway. You don't have ignition, you don't... Okay? Try and remember it. To begin with, let's review the magneto essentials. That's on page 2, by the way. Magneto definition: it is a mechanical device for generating electrical current to ignite the gaseous mixture in the cylinder of an internal combustion engine. Hopefully we all know that. The superiority of a magneto ignition in this field stands out because one of its cardinal features is that it is entirely self-contained, requiring but a small amount of energy from the engine to produce a powerful spark. The essential parts are a magnet or magnets, a winding or windings, a circuit breaker, in this case points, fourth a condenser, and a separate ground cutoff switch for the ignition. A high tension magneto is a high tension magneto that's one that is self-contained. That is, both the primary and secondary windings necessary for the production of a spark. Spark is a luminous path produced by the incandescence of the air gap when broken down by the electrical discharge. The space is afterwards filled with metallic vapors given off by the sparking electrodes of the spark plug. Now, you can't crawl inside the cylinder and smell that, but you can smell it outside. The cycle of operation of a high-tension magneto is as follows. The rapid reversal of the magnetic field and the flux surrounding the primary winding produces an alternating EMF or electromagnetic force current. The cam operating the breaker points is so designed that the primary circuit remains closed during the period when the induced voltage is growing. During the point closure, the induced current rises steadily in value. At a predetermined instant, the breaker point contacts open, releasing the EMF. This sudden rupture or opening of the primary circuit causes an instantaneous collapse of the magnetic field. Well, got to remember the laws of nature. Everything tries to go back to zero or the least possible point. The primary field is surrounded by the secondary windings, and an enormous voltage is induced into the secondary winding at this instant. This voltage conducted to the spark plug wire is sufficient to cause a spark to jump between the electrodes of the spark plug and ground. After a short period of time, the rotating cam permits the points to close again, and the cycle of operation is repeated. The condenser is mounted in parallel with the points, and its purpose is to ensure there is no arcing of the contact points at this instant, and thus prevents any arcing and burning of the breaker points. The physical purpose of the condenser delays production of the high voltage due to rapid initial movements of the lines of force. If it were not for this delay, the voltage would be manifested at the breaker points, and they would not have a chance to separate properly. With its capacity valued in microfarads, a condenser should not exceed the minimum value necessary to produce the suppression of sparking at the points. In other words, you got to get the right value if you are replacing on any ignition system the condenser value. I said, don't watch to catch up with this electronic process, as we all know that the speed of electricity is equal to the speed of light. In olden day terms, this energy travels at a mere 186,000 miles per second. Who knew, eh?
Yeah.
The Coventry Victor motors in our Dispros use Lucas or BTH English magnetos with a small number of American-made Y-pack magnetos used in later models. This later change was made in an attempt to save money by lowering the engine cost and selling price using a more economical American component. Dollars count. Let's look into the easier to solve magneto problems that have happened on occasion throughout the history of Coventry Victor equipped distro boats. Built by Gravette, primarily, somewhere. The history is a great teacher. In the years that we have been caretakers of our Coventry Victor car, Margie, 1976 to 2013, she has only failed to start once after storage. This problem was due to dirty breaker points. Margie also started run on one cylinder only on 2 occasions. The first time this happened by a failure of the spark plug wire to spark plug connector, and the second occasion was caused by a worn carbon brush at the magneto slip ring or commutator. Not a bad record. For this reason, any failure of your ignition system should always be analyzed and treated in the simplest of forms. Things can and do happen in the day-to-day running of the boats. It's a given fact that natural kinds of wear occur over a period of time. So be very careful not to overdiagnose a minor problem and unwittingly make it into a major one. Look before you leap. That's the old adage there. Be careful to check the attached schematic drawing for potential trouble spots and bad connections. It could be a very simple thing to repair or refurbish. Remember, it's not always doom and gloom. There are good days and bad days. A few members over the years have not been quite so lucky and have experienced more serious problems requiring a rebuilding of the magneto. This may have been caused by an open primary or secondary winding circuit of the armature or a failed condenser. These high maintenance repairs are very expensive to make, some costing more than $1,000. This high cost is caused by the scarcity of people or businesses capable of knowing how to or capable of providing these very specialized repair services in today's throwaway or replace it society. Having thoroughly checked and tested all the basic potential mechanical or electrical problems, it may be necessary to remove and install the magneto for servicing. Good news. There is a low-cost electronic ignition system available from England that can resolve major magneto armature problems without having to remove the mag. I'll show you later how that works. If you do have to remove the magneto, it is recommended practice to carefully mark the camshaft and magneto drive gears and timing chain locations to visually mark and record the original spark timing. After wiping off any excess oil, this can be done by using common whiteout paper. Just everyday common whiteout correction fluid would do that. The Coventry Victor magneto utilizes a fixed lever spark control and is chain driven off the camshaft at a 1-to-1 ratio. The camshaft is driven off the crankshaft at a 2-to-1 ratio, running at 1/2 the speed of the crankshaft. For flange-mounted magnetos supplied without a drive socket, both of these have, this one here, I'll pass it around. It does not have a keyway for the drive socket for the magneto. And this is a Morris taper fit on both the drive gear and this shaft. So the timing of the engine, by the way, for these flange mounted magnetos supplied with a drive socket, these instructions are excerpted from the BTH British Thompson Houston Manual Instruction Book 1377. Right here. Recently obtained. 30 years I've been looking for one. Thanks to the power of the internet, friends. Get you out of the dark in a hurry. Maybe into the dark too. On 2-cylinder engines, always tying the magneto to the number 1 cylinder when setting up the magneto shaft. Also see that the contact segment of the number 1 slip ring is opposite the number 1 collector brush. And when I pass this around, you'll be able to see what I mean. This is the slip ring and the collector brush inside here, which goes to the spark plug leads. You rotate the crankshaft in the right direction until the number 1 piston is in the correct before top dead center timing position on the compression stroke. Then with the drive sprocket loose on the tapered magneto shaft, rotate the magneto shaft in its normal direction of rotation until the contacts are just about ready to open. Lastly, secure the driving sprocket nut on the magneto shaft, taking care to see that neither the crankshaft or the magneto shaft moves during that operation. Those 2 tapers will pull together, believe me, and they will hold till hell freezes over without a keyway in. They're designed to do that. For magnetos with a keyway, the sprocket, of course, has a keyway in it. You put it on with the keyway lined up, and to secure both units by tightening the shaft nut. Then tighten the magneto by adjusting the magneto drive chain position to have the points open 8 magneto teeth chain before top dead center. This will provide the correct positioning of the recommended spark advance timing. Why is spark timing necessary? I guess everybody here knows that. With a cylinder full of fuel and air mixture on the compression stroke, the timed ignition spark ignites this mixture and a flame front starts to travel across the combustion chamber. This flame front must reach its highest peak after top dead center of the piston travel. Otherwise, the piston would stop and be forced backwards down the cylinder in a backfire. We've all had that happen. Just like in the Coventry Victor factory, all the above magneto timing should be done in a clean workshop, well lighted, well heated, and air conditioned in the summer. With the cylinder heads and valve covers not installed, it allows for easy visual mechanical access to the motor. A clean metal top bench and a section of correct sized British sockets and wrenches with a nice cup of tea would complete the requirements. Nice work if you can get it. Jesus, did you see Paul on that boat out there? Laying on his back, feet in the air, hands underneath, working in the dark. That's a lot of fun, isn't it?
Oh, yeah.
Particularly for an 84-year-old guy with 2 new hips. Anyways, working on the motor on boat land is an entirely different thing. You'll probably bonk your head on the bridge deck a few times, spend a lot of time straining your neck trying to get your bifocals in focus on whatever it is you're trying to do, and your knees will hurt. If you happen to have any coarse reserved vocabulary in your system, it will probably burst out and be wrenched at the same time. I'm sure. Always try for option number 1, and if you can, be sure to call a Dispro friend for help. That'll fix it all the time. The Coventry Victor engineers designed a very tidy, fully enclosed motor. It is most unfortunate it did not provide any convenient visual timing marks for servicing the motor except for the crankshaft and flywheel hub mating. The flywheel to the crankshaft keyway is machined and located at the top dead center of number 1 cylinder crankshaft throw. It would have been nice to have a graduated rod or known dimension type of timing, but the angle of the cylinder head prevents this from happening. And I'll stop just for a minute here. We're trying to measure how far up the piston comes to top dead center in the cylinder head here. So on anything that isn't quite so British, you would use a timing tool in the spark plug hole and find the top dead center of the motor and adjust this out till you hit the timing mark, rotate it 1 turn, and when the outer mark appeared, that would be exactly 32 degrees before top dead center. If you had a micrometer, in the case of all the Chrysler engines, you'd go to 3.47 inches, and there would be the position before top dead center. You could measure it in there, but because this is not available, you can't get at it. So that makes it a little more difficult. There you can see, no piston in there, but that's the problem that you have, is this angle goes down and won't allow you to measure this way. That's a good example of an engine that's carboned up, by the way, if you want to have a look at that. These timing tools, again, are commonly used by Mercury Marine, Chrysler, all manufacturers to make it easy for to check the timing. But the British didn't want to do that. Covered Vector service manuals do not include any information on setting the magneto ignition timing. Instead, they defer readers to the individual magneto manufacturer for instruction. These too are not complete. For this reason, the writer suggests the following simple way to locate and accurately mark top dead center and the before top dead center location. Using a simple paper 360-degree wheel, this can be taped onto the flywheel. You line top dead center up with the keyway of the crankshaft, and that would automatically indicate when you were on top dead center. I don't think there's a little trouble getting that on there. You might have to cut a bigger hole, and also too, it doesn't lend itself to doing it with the coupling attached. You'd have to pull that back in order to do that. I'll cover that a little more later on. Using the degree wheel can be handmade or photocopied off the internet as shown. Could then easily and accurately be taped into position of the flywheel using ordinary masking tape to hold it in place. The correct top dead center and before top dead center can then be marked with whiteout fluid, machinist crayon, or carefully center punched for a permanent reference. And that's what I did on our boat when I originally put it together. I center punched the flywheel to allow me to see those marks. To locate the #1 piston on the compression stroke with the intake and exhaust valve closed, slowly rotate the motor in the correct direction of rotation with your thumb covering the spark plug hole, and you'll feel a positive pressure as this piston starts to rise in the combustion chamber. And then you'll feel the increasing pressure as it moves towards the top. In closing, remember, use only solid core high tension spark plug wire, and do not use R or resistor type spark plugs. Alone or together, they could severely stress your magneto's internal circuitry and cause expensive damage. Trust these notes and drawings will go a long way to familiarize with the information needed to service your motor. Any further personal knowledge or information you have and could supply and share with members would be appreciated. And now I need my man. Good. That's not as good as the drawing in your. Did you get the idea? But you can see the breaker points here.
Maybe you can turn the lights down, Joe.
Yeah, maybe we can do that now. Oh, that's better. I'll just point out the trouble spots. First of all, as I mentioned before, when our motor didn't start, it was the breaker points that were dirty. And one occasion, it was the connector from the spark plug wire to the spark plug. And on the other occasion, it was the carbon brush on the slip ring that caused the problem. But this definitely shows you the primary, the heavy winding, and the secondary winding, and the condenser in here, and the way things are pretty much together. This is not too relative right now, but that's how we're going to generate that energy in the primary circuit that becomes enough spark to spark the spark plug. And this is what the this drawing at the bottom indicates what that armature looks like when it's out. There's the nut, of course, to hold the sprocket on, and the primary and secondary windings in here, and the condenser, which is potted in this little container here. Another one there. So check those points particularly. This shows you the engine front view, or pardon me, a rear view. And that is the keyway, which is in the crankshaft and flywheel. And that is the #1 piston on top dead center. I think I've indicated that in all of your drawings there. Now, there comes a time here, somebody's going to ask me about this. It says recommended 20 degrees before top dead center. But the Coventry Victor service manual says that the points should open at 28 to 30 degrees before top dead center. The point gap should be 10 to 12 thousandths of an inch. Now, exactly 10 years ago today, at Dwight Boyd's, I put on a little shop like this, and when I distributed this drawing, Paul Doddington, who's overhauled these engines for donkey's years, suggested that there was a mistake. He said that the factory setting was wrong and that they should never exceed 20 degrees before top dead center. Now, I haven't had my engine apart in 10 years, in fact in 30 years, so I can't prove that. But he says that in his work on the engines, he's found that to be the best setting. But why did the engineers, like every manufacturer, go to the trouble of designing the engine and run it and everything and come up with all those figures if they weren't meant to be fairly accurate? And there's a few places where you can go wrong. And the one is when you're, for every thousandth of an inch difference in the point gap that you have, you're at 1 degree of rotation in the timing. Think about it. If your points are 13 or 14, that'd be 2 degrees more than what it should be. And the other thing is too, and all engines, not just the Coventry Victor, but every time that piston comes to top dead center, you have lost motion. It comes up to top dead center, and it's got to be there only momentarily before it falls down again. So you have that couple of degrees of lost motion there on the engine. So there's some variance on all of these settings, and presumably you put them together and it works fine. So I want to be careful of not disputing Paul's findings on this. But if it were my engine and I was taking it apart again, I would put the degree wheel on it and find out where it's working now. Because if that motor worked good for 30 years, where it was set, where it was working, you don't want to start messing with the timing. At least I don't. If you want to do it, that's fine. But common sense would tell you it's worked good for 30 years, it's got to work again. And if it's just short of a spark, then we'll find out what that problem is. But the timing was fine. That's all I can say about that. Yes, sir.
Joe, one of the reasons why the 20 degrees was more effective, I think, is for starting and for low speed running.
Yeah.
If you run this engine at 3,600 RPM, which is what it was designed for, at
Right.
28 degrees, you're absolutely right. But for low speed running and for easier starting, the 20 degrees would probably be more effective. The 28 degrees might cause some...
It used to be in the old cars you would retard the start for the
Well,
start.
and there's
then
no
advance
starting
it.
against it,
Right.
deal, so...
But this timing is set.
Yeah, it's fixed.
Right, fixed
Yeah,
timing.
no choice. So a little easier, so and again, that's where the practical impact of, working on a new people complain that we're
Yeah.
on well and starting to use, so if you back off timing a little bit, it probably starts easier and runs easier
Mike-
at full speed, but that's,
Yeah.
that's a big debate.
My contention is, if I was used to running the engine, it was set and running at 28 degrees. If somebody trains it to 20 on me, I'd soon know the difference. I'd be looking to behind, see what logs I were towing, because it would definitely affect your performance. That's 6 degrees of timing is a fair whack up. of the timing. If it's a couple of degrees, nobody noticed it. But from 28 to 20, that's fine. If it works fine, that's your motor. So, anyways, my suggestion was that you might like to just check it before that. And the other thing too is if you send your motor to Paul and have it rebuilt, you get that back with all that stuff done, and you don't have to worry about it.
Mine is set to 22 degrees before top dead center,
Right.
which works out to 7 flywheel teeth before top
Seven,
dead
yeah,
center.
that's, and there again,
And that,
7 flywheel teeth, that's a bit of a, that could be another thing too, because you have slack in the chain when it's
Yeah.
worn. And it, that's just the setting, you say it's 7 teeth.
7 teeth
Yeah.
before top dead center. And it's deep.
You're 7 teeth. Paul recommended 8.
8 is the 28 and a half, 8 is the 28 degrees.
Yeah.
Or 8.4 teeth is the 28 degrees.
But anyways, getting back to the degree, well, I guess maybe you could, do another one here. This is some other trouble points that I wanted to put here. This is your magneto here, and this magneto lead, which comes out of the magneto housing, it goes through the key switch to ground. On more than one occasion, people have hooked that up to battery. And guess what that does? Puts 12 volts through the primary winding of the magneto, and you got an expensive repair in your hand. So you should really flag that and make sure that magneto wire, in this case, goes through the key switch to ground. And that ground is conducted from the oil gauge tubing to the dashboard in the case of the Dippy. So